Alright, so we do have the test, and it's that test that I sort of did in the earlier example. If you're finding inverses, you want to make sure and test that you actually found the inverse function. We'll make sure they undo one another. So if I take the composition, and you have to check both directions, because sometimes it works one way and doesn't work the other way if you made a simple algebraic error. They both have to be true in order for it to be an inverse. So again, you have to check both ways. And so when you take one function, plug it into the other function, they should undo one another and leave you with just the x value. All right, so we've got our two functions here. I've got the f of x, which is x squared plus 4, and then its inverse, which is the square root of x minus 4. And instead of taking my word for it, test that they really are. So use this test and check to see that they're actually inverses. And so we're going to test, we're going to take f of f inverse of x and see that it is, or f of g, as I'm saying g is the inverse. Alright, so I'm going to take f, plug in the function square root of x minus 4, and so remember I'm plugging it into the f function, so square root of x minus 4 is going to be plugged in here for x. And so it's going to be square root of x minus 4 squared plus 4. Well, the square and the square root undo one another. Leave me with x minus 4, x plus 4. Well, the x minus 4 undoes the x plus 4 and leaves me with just x. So it checks in that direction. All right, but now I check in the other direction. So g of f of x. So I'm going to plug into g x squared plus 4. And so again, it's going to go in here for the x term of g, and so it's going to be the square root of x squared plus 4 minus 4. And so we drop the parentheses x squared plus 4 minus 4. Well, the plus 4 undoes the minus 4, leaves me with the square root of x squared. Well, the square root undoes the square and leaves me with x, and so it does check. Yes, g of x is the inverse of f, so I can write it f of x inverse. All right. Now graph both and see that they do reflect and give the domains and range, and again, they should be opposites. All right, so they actually gave me the domain of f of x. We've limited it to the x is positive. This is already given my limited domain. So I already know f of x's domain is limited to 0 to infinity, which means that should be the range. I'll draw them a different color, so range, and we'll check that it is. All right, so first, graph them. So I'm going to draw my xy plane over here because it didn't show up. So there's my x-axis, y-axis. All right, I'm going to draw my original function f of x squared, but remember, I'm only drawing f of x, which is equal to x squared plus 4 when x is positive, greater than or equal to 0. And so it's the x squared function shifted up 4 units, so 1, 2, 3, 4. I might mark off some dash marks just so I have them to use, and I'm going to go ahead and graph my, oops. Keep hitting my erase button. So I'm going to go ahead and draw the line as a dotted line. That's that line, x equals y, which it should reflect over. All right. Now I'm going to graph it. So shifted up 4 units, so it starts at 0, 1, 2, 3, 4. So 0, 4 is where this one starts, 0, 4. And then 1, 5 is another point, just to have 2 points. So there's 1, 5. And then again, it has the parabola shape open up. So there's f of x, where x is greater than or equal to 0. All right, so the other function should reflect over that line, and it does. If I plug in my g of x, which again is my inverse of f of x, I've tested it, was the square root function x minus 4, it should reflect over that. And so if I plug in points, so first of all I'm going to plug in, I can't plug in 0, right? I can plug in 4 is the first value I can plug in. All right, that gives me 4, 0, which it should, right? That reflects over, it should. And then if I plug in 1, not 1, sorry, plug in 5, it should give me out 1, right? If I plug in 5, it should give me out 1, and it does, right? And then it has this shape, 5, 1. And so they are reflected over that line y equals 0. And graphing's where it'll sort of help me with my range. Alright, so I'm going to start with the range of the red function. So the red function's range goes from 0 to 4 to infinity. Starts here at 4 is the lowest value and then shoots up to infinity, 4 to infinity, which should be the domain of the blue function. And it is. The domain of the blue function starts at 4 and goes to infinity. And so the domain and ranges flip on invertible functions. They reflect over that line y equals x. And so that's an example of an inverse function, testing it, and then what the graph looks like. And we're going to do more with finding them in the next section. So as an example where you're given one.